In this video, we're going to go through the equation of the line of best fit, also known as the regression line. So in this question, we've got on the y-axis, we've got the cost in pounds, and on x, we've got the distance traveled in miles. Now in statistics, the variable on the y-axis is called the response variable or the dependent variable, and the variable on the x-axis is called the explanatory variable or the independent variable. Now the reason why the y value is called the response variable or the dependent variable, because in this case the cost will depend on the distance traveled by the taxi. Now in this case we want to describe the correlation for the scatter graph, so we can clearly see it's a positive correlation. Part B says work out the coordinates of the mean point of x bar and y bar for the data. So we need to work out the mean of x and y. So we can get our calculator and type it straight in. So we get 8.4 plus 6.6 plus 4 plus 2.6 plus 5.5 plus 8.9 plus 2 plus 10 plus 4.4 plus 7.6, close brackets. We've got 10 journey times, so it's divided by 10, and that gives me a value of 6. So x bar is 6. Now I want to work out what y bar is. So that's 10.2 plus 8.8 plus 7 plus 5.9 plus 8 plus 10.6 plus 5.2 plus 11.5 plus 7.3 plus 9.5, like so, divided by 10, and that gives me an answer of 8.4. So this will give me 8.4 here, and that is going to be the y bar or the mean of y. So we've got 6, 8.4 for the mean of x and the mean of y. Now it says to draw the line of best fit. Now when you draw the line of best fit, the rule in statistics is the line of best fit must pass through the mean of x and the mean of y. So let's figure out what's going on. So on the x-axis, we've got 10 squares represents 2 miles. So 5 little squares must represent 1. So this is 3. This is going to be 5. This is going to be 7. This is going to be 9. And this is going to be 11. So likewise, the same on the y-axis, is 10 squares is 2. So 5 squares is 1. That's going to be 3. That's going to be 1, 2, 3, 4, 5. That's going to be 5. That's going to be 7. That's going to be 9. And that's going to be 11. So that means if 5 squares represents 1 mile, that means 1 little square must be 0.2 miles. So now we can figure out our scale. So we want to plot 6 and 8.4. So now we can take this color for the mean of x and y. So go to 6. Don't forget this is 8. This is 8.2. This must be 8.4. So I'm going to write a little code for the examiner that this represents the mean of x and the mean of y bar. So x bar and y bar, right? So now that we've got that, we can say, right, I want to draw the line of best fit. So remember, the line of best fit must pass through the mean of x and y. It's a very important rule in statistics. So I'm going to hold my ruler there. It's got to be very precise. I'm going to get a green pen, and it's going to cut through that mean of x and y like so, and it definitely passes through the mean of x and mean of y. So now we can say the following. Well, we want to work out the equation of the line in the form y equals ax plus b. So we could write it down, y equals ax plus b. Now in statistics, this is the equation of the line of best fit. So what we want to do, in order to work out the gradient, we need to choose 2 points on our line of best fit, i.e. the green line. Well, what I'm going to do is choose 2 points that we definitely know. Well, I know that the mean of x and the mean of y is 6 and 8.4. So I'm going to say 6 and 8.4 definitely belongs to my line. So that's going to be x2 and y2. And then the obvious here is this. Well, 4 is my intercept. That means that the coordinate of that is 0 and 4 because x is 0 at that point. So I've got 0 and 4 here. This is going to be called x1. This is going to be called y1. And the formula to work out a, the gradient, is going to be y2 minus y1 over x2 minus x1. So in our case, it's going to be 8.4 minus 4 divided by 6 minus 0. Now remember that if I start off with 8.4 minus 4, then on the denominator, it must be in the same order. It's got to be 6 minus 0. So then that's going to give me the following, that 8.4 minus 4 is 4.4 divided by 6. Okay, now I can say that if I get my calculator now, I can work that out. So I can do 4.4 divided by 6. That will give me 0.73. So 0.73 is the value of A. Now, if I look at the mark scheme, the examiner accepts anything in the range of 0.67 to 0.87. Now, our answer of 0.73 lies in that range, so we're fine. Now, B is the Y-intercept. Now, we know that the Y-intercept is at 4, so it cuts the Y-axis. So we're now in a position to write down the equation of the line of best fit. So the equation of the line of best fit is AX plus B. Well, I know what A is. A is 0.73, so it's going to be 0.73x plus the y-intercept, which is 4. So that is the equation of the line of best fit. Then for part E, it says, explain what the value of A and B represent in this context. So we can say the following. A is the gradient, so that means for a 1 unit increase in miles, that means, in other words, for every 1 mile. So for every 1 mile traveled, the cost will increase. It will increase because it's a positive gradient, so it will increase by 73 pence. So for a unit increase in miles, so for a 1 mile increase, the cost will increase by 73 pence. That's how we interpret the gradient in this context. Now, that's what A is, the gradient. Now, if you want to interpret the y-intercept, so if you go to our scatter graph here, now it cuts the y-axis at 4. That's when the distance is 0. So we can say, when you have traveled 0 miles, when you have traveled 0 miles, the cost is £4.